The last of the definitions then that we're going to use in objectives 1 through 5 is a definition of something called specific heat. And we're going to use that definition of specific heat to define a unit of measure which we'll call the calorie. And a calorie is a measure of, is derived from our measure of specific heat. So we don't need to memorize the numbers on this table. There's two things that I want you to get out of this table that I'm showing you. The first thing that I want you to get out of it is that the specific heat of water is defined as 1 little c calorie, and I'm going to call as another kind of calorie a big C calorie in just a slide, in the next slide. So a little c calorie is per gram degree C is the specific heat of water. So the units on specific heat are little c calories per or divided by grams degrees C. And for water we define that as 1. So another way of saying that is how much heat does it take, and that's the energy that we're putting into the system, to increase the temperature of 1 gram of a substance by 1 degree centigrade. So it takes 1 calorie, 1 little c calorie, in order to raise 1 gram of water by 1 degree centigrade. And by definition, that specific heat of water is called 1.000. That's the first thing that I want you to take from this slide. The second thing I want you to take from this slide, again, I'm not asking you to memorize any of the numbers on the right-hand side of this table, but what I do want you to see is that substances like iron, aluminum, copper, gold, lead, in other words, metals, are better heat conductors. And when we say they're better heat conductors, we're saying in mathematical terms that they have a lower specific heat. In other words, it doesn't take as much heat to raise the temperature of 1 gram of lead by 1 degree. And so they have a lower specific heat. So that's all you need to know, is that metals are better heat conductors and that water is a good heat insulator. That's the number 2 thing that you need to take from this slide. So just to recap, the 2 things that I want you to get out of this slide are that water has a specific heat of 1 calorie, 1 little c calorie per gram degree centigrade. And the second thing I want you to get out of this is that water is a better insulator and metals are better conductors, and that means that metals have a lower specific heat than water does. We're going to use this to define a concept that you've probably heard before, and that's the idea of food calories. And food calories, even though they have the same name, have a slightly different symbol than specific heat calories. Specific heat calories have a little c cal, and food calories have a big C cal. And it turns out that there's 1,000 specific heat calories in 1 food calorie. So I'll call the food calorie a big C calorie, and I'll call the specific heat calorie a little c calorie. The one we were introduced to on the previous slide is a little c calorie, and there's 1,000 of those in 1 food calorie. And then the next bullet point in this slide says that 2 slices of cheese pizza, which we go down this table and we look at, again, not to memorize these numbers, but just understanding that this has a lot, this food, a cheese pizza, has a lot of caloric value. That is, it has a lot of energy that's tied up in it. And we'll talk about how energy is tied up in food molecules a lot when we get to Module 3. But for right now, we see that 2 slices of cheese pizza is an approximate food calorie count, or big C calories, of 800 calories. And that turns out, remember, that we can use that food energy, store it in our bodies, and then use that to do work. And the work that we're doing in this case is about 90 minutes of playing basketball. So about an hour and a half of playing basketball is what's required to work off 2 slices of cheese pizza, which I find profoundly depressing. I don't know how you would see this. It says in the slide here that 2 slices of cheese pizza, or 800 food calories, 800 big C calories, will heat about 8 liters of water, which is about 2 gallons of water, from freezing to boiling. And the question is, how do I come up with stuff like that? Okay, what was I thinking when I came up with that? What was the idea behind presenting that? And what I want to do is convince you that this bullet point hides a calculation that I can make using the dimensional analysis method that we used in Module 1. So I'm going to take you back to, I have it worked out here on my Elmo, and so I'm going to show you how we convert that pizza slice at 800 food calories or 800 big C calories into the idea of heating up 8 liters of water from freezing to boiling. So using dimensional analysis, we know that 800 food calories, 800 big C calories, we can convert and cancel out the units by going from big C calories to little c calories. So we need to do that in order to use the specific heat of water that we learned 2 slides ago. So I'm going to cancel out the units of big C calories, and this is going to leave me with units of little c calories. There's 1,000 little c calories in 1 big C calorie. So remember, using dimensional analysis, that just turning this into a fraction and multiplying by 1 and just changing the units. Remember, the definition of the specific heat of water, and it's water that we're concerned with, is that 1 little c calorie, the units are going to cancel, is 1 gram per degree C. So that's the definition of specific heat that we used earlier from the earlier table. Remember, that was the number 1 thing that I wanted you to get off of that slide. That cancels out our units so that now by multiplying 800 by 1,000 by 1 on the top of this equation and 1 by 1 on the bottom of that equation, so that makes it easier, that 800 is 8 times 10 to the 2, and 1,000 is 10 to the 3rd power. So altogether, that gives me 8 times 10 to the 5th grams per degree centigrade. So that's the amount of energy that I'm going to get out of this slice of pizza. To go from freezing to boiling for water is 100 degrees centigrade, because I'm going from 0 degrees centigrade to 100 degrees centigrade. That's also equal to 10 to the 2nd power degrees centigrade. So 100 is the same as 10 to the 2. It's 1 followed by 2 zeros, as we learned earlier. We're going to need this again when we talk about pH. So that I'm taking my grams per degree centigrade and dividing by the number of degrees centigrade that I need to climb here, the amount of heat that I need to put into the system. And that tells me that I'm going to be able to heat up 8 times 10 to the 3rd grams when I divide this out. Remember that to divide exponents, I'm just subtracting 5 minus 2. So I'm just subtracting these exponents, and that gives me division of exponents. So this is going to give me 8,000 grams, or 8 kilograms. And remember that a kilogram of water is equal to 8 liters of water. So this gets us back to the statement that was on the previous slide, that 2 slices of cheese pizza, which is 800 big C calories, will allow me to turn food into work, in this case heating up water using exergonic reactions, and that I'll be able to heat up about 2 gallons of water, or 8 liters of water, from freezing to boiling using the energy that I have in 2 slices of cheese pizza.